Lusitania began sea trials, impressing the Admiralty by achieving speeds of over 25 knots. But there was a problem. At high speeds, the ship would vibrate in exactly the same way that a ruler vibrates when you ping it off a table. The bow and stern shook so much that they became uninhabitable. Now, that was a problem because at the stern there were important areas such as the second-class dining room which obviously had to be used. They needed to find out what was going on, and they had to have a solution. It turns out the vibrations were caused by interference between the wakes of the propellers. Lusitania had 4, one more than most ships, which was needed to transmit the engine's power to propel the ship to record-breaking speeds. For efficiency, the inboard propellers rotated inwards and the outboard propellers rotated outward. This meant that the water between the propellers all flowed in the same direction, cutting down on inefficient eddy currents and things. But it also meant that as the blades rotate, they all throw water against the hull at the same time, 1 hit per blade per rotation. Not only that, but if you look carefully at the propeller blades, you'll notice that they're not in the same type of water the whole time. During this part of the rotation, they're in the disturbed water near the hull, and during this part, they're in the clean water away from the ship. As the blade travels through the different types of water, the shocks that it feels are passed up and into the ship's superstructure. When the propellers rotate at a certain speed, those shocks can match the resonant frequency of the hull, inducing violent vibrations across the entire ship.